6.2 is solving systems using substitution. So these are our steps that we're going to look at. So first step is put one of the equations in either x equals or y equals form. Often I see that students always want to try to put them in y equals, when sometimes that causes you to do more work than you need to. If something's already in x equals form, you can use that. We're going to then plug everything into the other equation, solve the resulting equation that you get, and then plug that answer back in so that you get an ordered pair. Because remember, the answer to a system is where the two lines intersect each other. Okay, so solve by substitution. So step one was put them in either x equals or y equals form, which we actually have both of them like that. So now we are going to substitute everything here, since this is saying y equals 3x, into the y there. I want you to think about this as like a nickel, and this is 5 pennies. They mean the same thing. They just look different. So I'm going to take these 5 pennies and trade them out for this nickel in this problem. So now I'm writing a new equation. So this becomes 3x equals x minus 2. So all I did was replace this y with the 3x here, and now I'm solving. So I'm going to subtract x. I would divide both sides by by 2, and I get x equals -1. So that is part of my answer. I'm not all the way done though, because step 4 was plug that back in to get your answer. So it does not matter which of these equations you plug it into, you will get the same thing no matter what. So if I plug it into the top one, 3 times -1 is -3. So my final answer is the point -1, -3. So this would be the point where these two lines intersect each other. All right, so part B, we have this one in y equals form already again. So I'm going to take all of this stuff that y is equal to, and I'm going to replace the y below it. Okay, so the only thing that changed was this y became this. So now I'm going to simplify and solve. So I have a 4x plus an x is a 5x. I'm going to subtract 1 from both sides. Divide both sides by 5, and you would get x equals 1. So then we're going to take that and plug it back in. You can plug it into whichever one you want. This top one is easier, so that's the one that I would plug it into. And I get y equals 2. So my solution is the point 1, 2. And make sure that you put the x coordinate first. Okay, part C. So on part C, we do not have either of them in x equals or y equals form, so I need to manipulate one of them. So I'm going to take this bottom one, and in order to put it in x equals, which looks pretty easy to do here, I'm just going to add y to both sides. So this now is becoming x equals 5 plus y. Now that this is in x equals, I'm going to take this stuff and plug it in up here for x. So now I have, okay, so the only thing that changed was this got replaced by this. And now I'm simplifying and solving. Y plus 2y is 3y. I would subtract 5. Divide both sides by 3. So I get a y value of -2. Now I need to plug that back in. So now I actually have 3 choices of where I could plug it in. I could plug it in here, here, or in my new manipulated equation. So I'm actually going to plug it in there because that's going to be the easiest. 5 plus -2 is 3. So my point is 3, -2. Common mistake here is to put the -2 first because that's the one you solved for first. Make sure you always put x before y, just like the order in the alphabet when you're putting them in a coordinate pair. All right, and part D. So this first one, I look at that equation and say, I want to put that in y equals form because that looks like the easiest thing to do. So I'm going to subtract 6x from both sides, and I end up with y equals 11 minus 6x. Now I'm going to take that and plug it in for the y in the other equation. Now I'm going to solve. So we got a little bit more work to do here. I have to distribute. Oh, sorry. This is supposed to be an x. Ooh, that would cause a problem. This is an x. This is an x. Okay, so now I have 3x minus 12x on the same side. So I'm going to combine those. I would subtract 22 from both sides. Divide by negative 9. And then plug that back in. So I'm going to plug it back in up here. Six times 3 is 18. 11 minus 18 is negative 7. So my point is 3, negative 7. Sorry, we kind of ran out of room on that one. Okay, and lastly is our story problem. It says your parents decide that you need to start paying your own phone bill. The first plan is $200 to start and $75 a month. The second plan is just $100 a month. After how many months will the cost be the same? What will that cost be? And if she signed up for 1 year, which plan would be cheaper? So first we're going to do what's called defining your variables. We've done this before. So I'm going to say x is going to equal months and y is going to equal cost. So I'm going to write two equations here. So plan one is $200. So the cost is equal to $200 plus $75 each month. Plan 2 is the cost is equal to $100 per month. So now it says after how many months will the cost be the same? So we can use substitution, set these equal to each other. So since they're both in y equals, I could take this and plug it in here. So this gives me 100x equals 200 plus 75x. And I'm going to solve. Divide both sides by 25. And you get x equals 8. Then after how many months will the cost be the same and what will that cost be? So that is going to be our y value. So if we plug that back in, y equals 800. So this means after 8 months of service for both plans, you've paid $800 for that cell phone. And then the last question, it says, if she signed up for 1 year, which plan would be cheaper? Okay, so if she signed up for 1 year is 12 months. So we could substitute this into both of them and see. So plan 1, if I plug a 12 in there, 75 times 12 gives us 900 plus the 200 means that plan 1 would cost $1,100 for a year. Plan 2, I have 100 times 12. That would be $1,200. So if she had it for a year, plan 1 would be the cheaper plan to go with. Okay, you've got 2 of them to try on your own. And your joke of the day. What do you call an alligator in a vest? An investigator. I think that's a really good one. All right, finish up those last two and have a wonderful rest of your day.